Hello and welcome to video 4 of the Pebble tutorial series. In this video I'm going to show you how you can create your own voice powered task list using the inbuilt microphone and dictation service that's available on the new Pebble SmartWatches. So this won't work for the older ones, but it will work for the newer ones that have just been released. Okay, so now in this one here, what we're introducing quite a few new concepts. So unlike the previous apps, which were all watch faces, we're making a full app, and this is going to contain multiple windows. So the first window that loads is the one on the left-hand side, and this will be the menu of tasks that you've already created, you've already recorded. And if you were to scroll, you can click up and down, and it will scroll through those apps. And then if you middle click, it will then take you through to the task detail window. And if you don't want to delete a task, then you can, instead of just single clicking to get through to the task detail, you can hold middle click and it will delete the task instead. So this uses the dictation service, which is what's used to transcribe from voice to text. It also uses menus, so we show you how you can create a menu because your task list really is just a menu of tasks. Also, we look at how we can use the persistent storage. The Pebble has a certain amount of storage on the watch itself, and we're going to be using that today rather than saving tasks to the phone as backup or anything like that. And how we can use the accelerometer service to handle single and double taps. Okay, so before we start, you're going to need to install the Pebble SDK, which I hope you've already done. If not, have a look on video 1 of the Pebble tutorial because it teaches you how to do that and it gives you some links on how to do that quickly. Once you've done that, you're going to need to download the whole project that I've uploaded to GitHub here. What we're going to be doing with this project is I'm just going to be talking you through the code. I'll be pasting code in bit by bit and talking through so that we can see how the whole thing works together. I won't be typing it line by line because it's about 200 lines of code, so that'll take quite a while. So I'll just be pasting it in sections and talking through how those sections work so you can get a feel for the code. So the first thing you're going to need to do if you've installed the SDK is you need to create a new project. So we use the command in the command line Pebble new -project task list. Okay, so what we've got here is I've got the command console and I'm going to do Pebble new project and then I'm going to call it task list. As you can see here, I've created a folder on my desktop called Pebble and all my tutorials are going to go in there. So you're going to want to do that. In fact, actually, there we go. And that's once you've done that, it will then create yourself a new project. You can see new project task list there. And if you were to go to File Manager, then here you can see it's created a folder here. This works identical for Windows and Linux. I'm using Linux because I don't like the new version of Windows. So we go to task list. Now here is create a few files. W script you can just completely ignore. That's the compile script. The first thing we're going to edit is the package.json file. So open up that in your favorite editor. There we go. And this is all okay. We can leave all this. You can change this to however you want, the author, all these different things. There we go. I'm going to change my author to learn. There we go. Learn. There we go. And the one thing we are going to need to do though is at the moment we haven't activated the speech capabilities, which does the speech to text. So we're going to need to create a new bit here, add down the bit here. We call this capabilities. There we go, capabilities. And the one capability we're going to need to give it is the speech capability. Speech. There we go. Good. Done. So now what that's done is, oh, hang on, not quite done. Let's close that brackets. There we go, good. Good. So now what we've done is we've enabled the speech capabilities on the watch so it can record things. So that's all we really need to do to our project setup file here, the main package file. This is just configuration details. We don't need to change any of the rest of this. Now that's done, we need to move on to the source file. So we go to source C, because we're going to be a C file, and we go to our tasklist.c. There we go. It's already filled this in with a lot of detail. Now normally we would keep this and build on top of there, but we're just going to delete it and start all over again. There you go. So now the project setup is complete and we can start coding our main file. So in order to code the main file, the first thing we need to do before we start talking about anything else is we need to include the Pebble code, the Pebble library, so that we can use the inbuilt functions within the Pebble rather than just the standard C library. So we put an include to the pebble.h there, the header file that contains links to all of the Pebble code that we need. Also, we're going to need to create a few variables, well, constants in this case, for things that features of our list. So we're going to have to let the program know what's the maximum number of tasks we're going to save, which we're going to save 35. And we also need to put a limit on how long each task is going to be. So I've said that each task is going to be a maximum of 100 characters. And also we're going to look at it in a bit when we start to do our storage, is when we save anything to the persistent storage on the watch, we need to tell it where in the storage it's been saved to, and we do that by using a storage key. Now I'm just going to say, okay, we're going to have two keys today. Key 1 is going to be the task list, so that's where all the task list is stored, and then key 2, which I've not defined here, is going to be the length of the task list, because we need to know the length of the task list when we are saving and retrieving. Okay, so we do that. Now, speaking of which, we need to create our task struct as well. So our each individual task is going to be a struct, and it's going to be a simply a struct of a text. That's all it is. We're putting it inside a struct because we might want to change the task list later on. So we might want to add other things like due dates into that struct, or priorities or things like that. So by putting it into a structure, it means that we've got all that data together. There we go. So we said it's going to be a struct, and each in that struct is just going to be some characters called text, and of the length, maximum 1 length. So now the memory, the computer knows exactly how long each task is going to be as a maximum. There we go. So now we've done our struct and defined our task struct. What we're now going to need to do is we're going to need to add in a few more bits and bats. So the first thing we're going to need to do is we're going to need to create the 2 windows that we said we were going to create. So there are just 2 screens, the main window, which is the task list menu, and the task detail window. If you've already watched the Pebble tutorial series 1, then you'll know what these are all about here. If not, I would say go watch this before you start working through this video. Here we just need to create pointers to each of the menu windows that we've got in memory later on. Okay, now into each of those menus, each of those windows, we're going to need to add some layers, which is where the actual text gets displayed. So on the main window, we're going to need the menu layer. So there we just create a menu layer, and then we're going to populate that menu with our task list. And then on the task detail window, we're going to have a text layer like that. There we go. Okay, that's the main bit there. That's okay. Also, all of the tasks are going to need to be stored when we're creating these tasks. They're going to need to be stored inside of an array. So we need to create an array, which is a list, a fixed size list, really, if you're coming from Python, an array of tasks. And so here we just say, okay, we're going to create a task list, an array of tasks called s_tasks. And it's going to be the length of the maximum task there, 35. So it's going to have a fixed length there. Good. So all of our tasks are going to be stored in there in memory when we're using it, but each time we create a new task or delete a task, we're going to save and update the persistent storage. Because otherwise, as soon as we close the task list program, it would just delete all those tasks because arrays just exist in memory. Okay, good. Now, working with that number of tasks, we're also going to need to keep track of how many tasks we've got at present. So we need a variable for that. An integer is just going to store that. And we also need to know when we're going up and down the menu, which task we've currently selected. So when we do select a task from the menu, we know which one to go into the detail view or which one to delete. So we need an integer called selected tasks. Now, because we're using the dictation service, we're going to need to create a new dictation service pointer. Dictation session pointer, so that every time we create a new dictation, it starts this recording session and then deletes it at the end. And also, because we're going to be using the tap, because we're going to be doing a double tap on the watch, there's no way of the watch, there's no inbuilt double tap feature. So what we need to do is basically, although there is a tap feature, so it recognizes when the watch has been tapped, we need to have create our own little function so that when it taps once, it remembers when it's been tapped. And then if you tap it again, it works out how long it's been since the last tap. And if it's been less than half a second, we count that as a double tap. In order to do that, we need to remember what time the last tap was. So that's where we create this last tap time. There we go. Also, when we're deleting items, we need to keep track of when we last deleted an item. Because we're doing the long press to delete, then if we just long press delete, what can happen is you do the long press, it deletes that item, it immediately goes back to the menu, and then you don't notice and you end up deleting multiple items. So we want to force a bit of a delay between the deleting of items. So we need to keep track of the time and when we last time deleted something. We'll use that more in a little bit. Oops, hang on, that's okay, good, there we go. Also as well, if we're doing these deletions and things like that, and the timings, it's a good idea to define some constants here so that if we're messing around with changing the double tap timeouts or the cooldowns, then if we've got these numbers here at the top, we can easily tweak those numbers and we know where that will then affect the whole program. So it's a good idea, rather than putting these numbers, hard coding those numbers down the bottom in the actual functions. Let's keep them at the top so that we can edit our program and debug it a little bit more easily. Good. Okay, so that's the main part of the setup before we start doing our main program. And now we're going to move on to the bit about saving and loading tasks and have a talk about the persistent memory. Okay, so when you add things to the list of tasks, that's going to be in an array. Now that's fine, but the arrays themselves aren't permanent, which means as soon as you close the application, it's going to be deleted. It's going to disappear back from the memory. So every time we add a new item to the task list or delete it, we need to update the persistent storage. Now there's different storage that you can access when you're creating apps for your watch and things. The smallest but easiest to use is the persistent watch storage. Now this has a maximum of 4 kilobytes per app, I believe, as best as I can find, which means that we're quite limited, and hence why I've got that 35 task limit on there. And that's because if you've got 100 characters per task maximum, and each character uses about 1 byte, then 100 multiplied by 35 is 3,500. So that's where you get the 3.5 kilobytes. So that's got to be under the 4 kilobytes. So that's why we've got a 35 task list. If you don't want to have that kind of limit and you want to do a bigger app, Then you need to use the Pebble JavaScript local storage, Pebble.js local storage on the phone, and that will give you 5 megabytes or more, depending whether you're using local storage, or apparently you can use the indexed DB for something more complicated, which is over 100 megabytes of storage. But you can see the main thing we're going to use today is the on-watch one, using the persistent storage. And this is just blocks of memory that we allocate, and we just save our array or integers, whatever we want to save. We take them wholesale and put them into the memory storage. So let's have a look at that. Now we're going to be using 2 keys, as I said before. Key 1 is for the task list. So we're going to save that into persistent storage, and key 2 is going to be for the task count. Okay, so let's have a look at how that actually works. So the first thing we need to do is we need to be able to save tasks to the memory. So saving tasks to the memory is really quite simple. Once we've updated the array, which we're going to do elsewhere, all we need to do is we just need to paste in here. We just need to save the actual tasks using the persistent write data functions here. So all we do is we call the persistent write data. We give it the storage key that we're going to save it to. We give it the thing that's going to be saved, and we give it the size of the object that's going to be saved. So here we know that the task, this is a nice little simple function that gets called at compile time, that calculates how big the a task would be, and then you multiply that by the task count. So basically it goes to this struct here, works how big this struct is here, and then multiplies that by the task count, which is max tasks. Oh no, it's not max tasks, it's just task count. Where's my task count? Multiplied by the number of tasks, so that we're not using unnecessary space. So it knows to paste it into there. And we also here have the storage key as well, which is the storage key plus 1. So this one is 1, which makes this is 2, and this is going to be the task count. So this just says, okay, what we're going to do is we're going to take all of this and send it into the persistent storage. There we go. Okay, so that's how we save tasks, which we'll use throughout the program. And then we also need to be able to load tasks as well. And we do that using the load tasks function. There we go. Now we can see it here. And all we do here is we just go to see if the tasks have been stored in memory. And if they have, all we do is, first of all, we read this. We read the storage key plus 1, which is 2, which is the task count. So first of all, we find out how many tasks we have using the first line of code. And then if the task count is greater than the max count, then we just use the set it to the max tasks, because we shouldn't be doing that. We want to limit it to 35. And then what we do is we read the data from the storage. So we read in the data using the storage key, which is 1. We're going to be saving it to the s_tasks. So we're going to be loading it from the memory into the s_tasks array. And then we tell it the size of each task by the task count, so that it knows exactly what sections of memory it's taking from the persistent storage, how much data it's going to be reading from the memory, and then it reads that into your task count. And if there are any tasks, so if there aren't any tasks in the persistent storage, then it just sets the task count to 0, rather than, because otherwise it wouldn't be set to anything. Okay, good. Okay, so now that we've got all of the initial setup sorted, let's actually start coding our application. So the first thing we need to do is we need to set the initial project initialization up, and this follows this kind of flow here. So basically we start the application. When the application starts, so you click on it, then it immediately goes and finds the main function. And the main function it basically starts the initial, what we do is we get it to start the initialization of the application, the setup and the loading of the application. Now the initialization, we've got 1, 2, 3, 4 things to do. First, we load the task list. So using the load from the persistent storage so that we get the tasks into memory. Then we subscribe to the accelerometer, which means we basically, so we know that when we start tapping on the accelerometer, it can start registering those taps. We can't do that until we subscribe to the accelerometer. Then we create the task detail window, which we just get that loaded, ready to start putting things into there. And then we create the main window, which is the one we're going to show at the beginning. And because this one here we're going to show in the beginning, we then show the main window and then we go inside of the main event loop. The main event loop is where your program will spend almost all of the time waiting for user interaction or waiting until you leave the program, and in which case you do some cleanup, release resources, and then exit the program gracefully. So let's get the initialization set up. So in order to do that, what we need to do is we need to do the main init. There we go. And this will be right down at the bottom of your program because we always start at the very end. You don't initialize the program until all the other code's done. So we do the main initialization, and this just says, okay, and this is the function that it looks when your program opens. This is the function that Pebble looks for to load first, is the main void function. And then we do the initialization, which we saw before. We set up the windows. We sit inside of the event loop waiting for user interactions, which we'll handle later with callbacks. And then at the very end, after the event loop dies, which means that we've pressed close on our program or pressed back most likely, then we deinitialize the setup. Okay, so let's do the init first of all. So the initialization function looks a bit like this. There we go. So first of all, we load the tasks, which calls that load tasks from persistent memory, which we looked at before. We load the tasks. Then we subscribe to the accelerometer service so that we can handle accelerometers values and the taps. Then we create our task window screen here. And we set up our window handlers for the main for the task window. The main handlers that we need to set up here really are what to do when we load that window, okay, which is at that point we need to go and get the item from the array, the task from the list of tasks, and then we need to put that on the screen and display that text window, which we'll look at in a minute. And then we need to unload. When we unload those task details, we then need to release all of those resources. Same sort of thing here when you do the main window. So with the main window, when we create, we need to say what's going to happen. So when the main window loads, then we're going to do the window load handler, which we're going to look at in a minute. And when we unload it, we're going to do the window unload handler. Once you've got all of this set up, you need to choose which one of these then you're going to display when the program starts, because whichever one of these you're going to display, which is the main window in our case, we need to push that to the window stack. The window stack is basically just like a stack of different windows, and you can put as many as you like on there, but whichever window is on the top of the stack is the window that's currently displayed. So we're just going to have one item on our stack, which is our main window, which is our main menu. So we're going to push the main menu to the stack, which means that it will then display it after it's all loaded up. Okay, so those are the main parts of the initialization that handles. Now, obviously, when we after we've done all that and our program ends, we're then going to need to deinitialize our program, which means we're going to need a deinit function, which is this one here. Okay, and it's pretty much the same as before, but in reverse, sort of. We need to unsubscribe from the accelerometer service so that we're no longer listening to that and taking up resources. If we close the program whilst any dictation is happening, then we also need to make sure that we destroy that dictation service so it's not hanging around in memory. And we need to destroy these two windows, the task detail window and the main menu window that we created. There we go. So that's the D-init of the program. That's the closing of the program. Okay, now let's have a look at loading that main window. Okay, so when we load the main window, which is how window loads. There we go. So let's have a look at the main task window, which is this one here, and what happens when the window loads. So when the window loads, we're going to need to create the full menu. So let me show you that here. And let's put that up. Let's put it up here. There we go. So that's going to go here. So when the main window loads, then what we're going to need to do is we're going to need to create our menu. Now, normally in Python, I'd do some sort of loop that loops through all of the different tasks and creates something for each of those tasks, but this works slightly different. And what we do instead is we create the menu window, the actual menu itself, dynamically using a series of what's called callbacks. So, and this bit happens here in this bit, just here, there we go. So let's just talk through the other bits of code and then I'll talk through this piece of code here. So the first thing we do is when we load the window, we get the root window, the root layer, which is the main window, and we need that root layer because A, we're going to have to put things onto that root layer, and B, we need to know how big the root layer is so that we can take up the full space available. And that's what this grect bounds does. It finds the bounds of the root layer, which in this case would be the 0, 0 for the very top left of the screen, and then it would be the width and the height. So this is just going to get a rectangle with some coordinates, some starting coordinates, in this case 0, 0, and then the full size of the screen, whatever size screen you've got for the Pebble. So that will actually do that dynamically. Then we create our menu, which is basically our task list. We create our task list there, making it fill the full bounds of the window by giving it the bounds thing that we've created here. Then we say that, okay, we're going to need to be able to handle clicks on there. Okay, so, and we'll talk about what clicks are going to be handled in a minute. And then we need to set our callbacks so that this will actually construct the full menu. So now would be a good time to have a look at those callbacks and see what exactly is being done. Okay, so let's have a look. Where's my callbacks gone? There we go. So these are the callbacks that are happening when you create the main menu. Okay, so the idea being is that when you create that task list menu, we need to find out how many sections we've got. Now in this case, really, you don't really want to do this because we've only got one section, which is just a task list of tasks. But in most menus, you might have sub-menus and subsections. So you might have a number of different sections. Our sections, but you need to tell the menu creator how many sections you're going to create so that then you can loop through those sections and create each section in turn. We're only going to create one menu section, so we'll create a callback that literally just returns one. So we know we've only got one section, which is our task list. And then for each of the sections, of which we've only got one, we need to tell it how high the header bit is going to be. So we use a callback for that called menu get header height. I've just done that wrong. Callback, and that will return how big that header is. Then we need to tell it how many rows that it's going to have. In this instance, the rows is going to be equal to the length of the task list, of the number of tasks that is. And then we then draw the header row, which is going to draw that little title that says task list or tasks. And then for each of the rows, or in our case, for each of the tasks themselves, we need to call the menu row callback, which will then go through and it will add each task in turn to that menu. Also, with all that as well, we need to say what we're going to do when you click a row. So we need to set the menu select callback, and you also need to say which is when you click a row, it then displays the task detail. We also need to have another callback as well set up so that what happens when the user long clicks a row, and that's what we call the deleting callback. So just to show you that previously, here we go, you can see this here. So we've only got one section. The section header is going to be called tasks, and that's the height of the section header. It's quite small. And then for each of our items in that menu, you can see here, we're just going to loop through and display the task itself. Okay, so let's have a look at those callbacks and let's see what they look like. Okay, so the first callback we've got is the get number of sections callback. That's really quite a simple one, and we're going to code that now. And all that one needs to do is return 1 because we've only got one section on there. So let's put that below the load tasks. There we go. And there you go. So this callback, get number of sections callback, will just return 1 because we've only ever got one menu section. Obviously, if you had a complicated menu, then you'd have to calculate how many it needs. Okay, so that's the first bit. There we go, which is the get number of sections callback. Next one is get number of rows callbacks. This will tell it how many rows that it needs on the menu. And ours is quite simple. All we're going to do is we're going to say, okay, if the task count is greater than 0, then we will return the task count because we want 1 row for each task. Otherwise, we'll return 1 because we want 1 row that's just going to be the row that we put in some placeholder text that says double tap the screen, please, to add a new task. Okay, so that's the get number of rows callback. So where's that one? So now we've covered the number of section, the number of rows, the menu get header height callback. This one needs to tell it how tall we're going to make the header menu. Now we could do this calculate manually in pixels if we wanted and say like 20 pixels or 30 pixels, but to keep things standard, we'll use one of the inbuilt constants, which is the basic header height. That means that on all our menus, we've got a consistent header height. That's one of the inbuilt constants that we've got there. So we have now got the header height. Then what we can do is we need to say which function is going to be the one that actually is responsible for drawing the header. Okay, which is quite simple, very, very simple. And all we need to do is that code there. And all it does is we create ourselves a new basic header. We tell this is the canvas. This is the name of the canvas it's going to be drawn onto. This is the cell layer on that canvas, which is calculated automatically when these callbacks are run. So the cell layer, which again ours is just section 1, that cell layer at the very top. And then we just say what we're going to put into it, which in this case is the word tasks. So that now is the header all pretty much done. Draw header. Now we need to say what are we going to do when we draw each row. Now drawing each row is a little bit more complicated. So let's show you this code. Basically all we need to do is what we do is we need to get the index. Every time this function runs here, the draw row function, all we need to do is, first of all, we need to calculate the index, which is the position in the array, and the position in the actual menu itself, so that we can go and get the item at that index from the array and then put it into the task list. So we use this index variable here that we created, and in order to get the index, the current index, we use this cell index row, which gets pulled from here, from the cell layer where we are. There we go. So what this does here, this cell index, the menu index, is this will get the it will get the current row and the current section. Now we don't need the section. This will provide us with the current row and the current section. We don't need the section because we've always got section 1, but that will get it in case you're going through different sections. And we go and extract the row from here using this bit here. There we go. So the index is, we go to the cell index and get the row that we're currently working on. If the task count is 0, so there's no tasks that have been saved, then we simply draw a nice empty thing here saying no tasks, and then double tap to add the task, and that will display in there instead. However, if there is, then what we do is, if the current index that we're going through is less than the task count, then we need to display the data from there. And we do that using this code here. Basically what it does is we create a new temporary buffer called display text. And this is the, we make this buffer, we need to make it big enough so it could hold any task, which is possibly 100 characters in length, plus some null termination characters at the end. So +4 is enough to cope with that. So we create a buffer that's the full length of any possible task, +4 to allow for any bits at the end. Then we use this strn copy, which is a really good way of copying things, because you can give it the thing to copy from and to, and you can give it a maximum length. Really good at stopping any overflow issues, memory issues, where we're going beyond this maximum 100 character length. And what we do is we say, okay, we're going to go to the stasks, which is the array of tasks, and we're going to go to that index with the one we've just been provided, like row 1 or row 2, and we're going to go and get the text from that, task. So it will literally go to the task, get the text within that task, and then we're going to add that in, save that into the display text buffer, which is the one here, being mindful that we do not exceed the maximum task length, so that it will trim it if it goes any further. Then once we've done that, we add the null terminator at the end by adding that to the end of it. And once that's done, then what we need to do is that if that task is quite long and therefore won't fit on the main menu, then what we do is we just truncate it. We truncate it and stick some ... at the end. In order to achieve that, what we do is we use this, again, the string copy function. And what this does here now is we take the original display text and we go to the from beyond the 27th character, and we just pop in ... on the end, and that finishes it with ... There we go. And we limit that to 4 characters, which means that ... it's going to be 27 plus 4 characters, including the display text here at the end. So that's a really, really easy way of just making sure, truncating it down to 27 characters plus the ... plus the null terminator in there as well. And that means that we've got now our display text is ready to be displayed on the screen with ... if it goes too far. Once we've done that, then we call the menu cell basic draw, giving it the canvas that we're going to draw onto, the cell layer, and most importantly here, the display text that we're going to display. So that will, for each of row, that will then go through and display the correct text. So that's how we handle the main draw row callback, which is that one. Now what we need to do is we need to handle what happens when we do a click and when we do a long click. So let's have a look, and let's have a look at the select callback. Okay, here we go. So the menu select callback, really pretty straightforward. All we need to do here is we need to say, okay, whatever row has been clicked, so we can get that from the cell index again, like we did before. So we work out which row has been clicked, which is the index. If it's been clicked on, if the index is, if the task count is 0, then we've got nothing to load, because you don't want to load that bit that says, that empty task that says, double tap to add. We want to be able to handle that. So if there aren't any tasks, we simply return, because if you do click on a task that doesn't exist, i.e. the little row that says please double tap to add, we don't do anything. But if there is a task and it's not gone beyond the limit of the task list, then what we need to do is we go and get the selected task index. We set that to the index that we've just got from the main index here. So now this variable selected task index now stores the number of the item that we want to display. And then we display the task detail window, which is this one here, pushing it to the top of the screen. Because we've pushed it to the top of the stack, it will then display. So that's how that one works there. Now, before we do that, actually, let's have a look at how that works, how the task window actually displays when that happens. In fact, no, if I will leave that for the moment, let's do the last one of the callbacks. So the callback for the delete callback, and we'll go through to the task window in a minute. So what do we do on the long click? Well, the long click, what we need to be able to do is we need to be able to delete whatever task has been selected. So we do that here using this function. So again, like before, we do the main callback, and we need to be given the cell index here on the main callback, which is what we use here to work out what row has been clicked, which item has been clicked. Obviously, again, like before, if there aren't any items in the task array, then we don't do anything. We just we just return, because there's nothing to delete. Otherwise, what we need to do then is we need to handle, we don't start deleting anything unless we are sure that there's been a half-second delay or more. There's been a half-second delay between the last time it was clicked, and that's what this code does here. We get the current time, here we go. And what we do here is if the delete, basically we just check here to see if the last delete time is, so if there is a last delete time, and the last delete time is greater, the difference between now minus the last delete time, so now minus the last delete time, if the time between now and the last delete time is greater than the cooldown time, which was that 500 milliseconds before. If it's not, then we return. Okay. So that's the other way around. That's which way I've done it. Yeah. So if now minus the last delete time is less than the cooldown time, we return, because we don't delete, because it's inside that safety window of half a second. If you're still holding the long delete button half a second later, that's your own fault, or at least that's how I've coded the app. Anyway, so if it's not inside the last delete time and you are ready to delete, then what we need to do, again, just make sure that the index that's been selected is not greater than the task count. So it is actually a currently available task. And then what we need to do is we need to delete the task. First of all, we delete the task from the array using this code here, which I'm going to talk about in a second. And then once we've deleted the task from the array, we then save that task list array back to the persistent storage, so that if the app closes, we've still got it. So what's going on here? Well, this is C programming's, in C, this is how you delete items from an array. Okay, so let me just show you how that works. Okay, because this piece of code here is quite useful and quite clever. So let's go through to that and let's see how that works. I'll ignore all of this. There we go. Item and removal in C. There we go. Okay, so let's say this is our array of tasks. Obviously, I've made this nice and short using letters. But let's say with this array here, and we want to delete item 3. Now, arrays are fixed in lengths, which means we can never make it smaller than what it already is. We can't change the size of it. So all we can ever do is move things around. So what do we do? Well, we start here from item 3, which is the item we want to delete, and we loop our way along. And all we do as we're looping our way along is we take the item. So if we loop for the number 3, we find out what is at index 3 plus 1, which is index 4, and we move that into here. And then we do the next one, we move F into here, and then we do the next one, we move G into here, and then we do the next one, 7, H into here. So we move it into there, each time copying it left along there. So you end up with something that looks like this. Now notice that the array is still of the same length, the array is still at 7, but what we've got here is all of the items has been moved along. What we need to do now is we need to tell the program that actually we want to ignore this last item here. So what we do is, whereas the original length here was 1, 2, 3, 4, 5, 6, 7, 8, including all 8 of these characters, now we update our number of items or length of items to 7. So now you still have an array of length 8, but we're deliberately ignoring the last item because we've squished it down, because we've moved all the items to the left, overwriting what was at number 3, which means number 7 contains some empty value, some redundant value that we don't want to include. So that's how that works in our code. And that's done using this piece of code there. We do a for loop. We start at the index that's going to be deleted, and we keep going until it's the length of the task count minus 1, because the last index is always going to be the length of the list minus 1. You can see that here. The length of the list is 8, so the last index is 7, because we start counting at 0. And all we do is we do I++, so it's going to go up, it's going to go 3, 4, 5, 6, 7, 8. And then for each time round, we find out what is at the task list index plus 1, and then we save that to the task list index. So each time round, it's copying left, copying left, copying left through that for loop. Once we've finished the for loop, we then need to deduct 1 from the number of items. So in this instance, the len items, we need to, or in our case, it's the task count. We just take one off the task count variable. So we're just pretending now that our array now has 7 items instead of 8. Once that's done, you then call the save tasks, which will then save all of the tasks up to that the length of up to the index at the task count, well, minus 1. Obviously then, once we have pressed delete and we've deleted an item, we set the last delete time to now, so that if someone is still holding the delete button after it's been deleted, then the safety kick here will kick in and it won't let you delete the next item. Once you have set that, updated that time, then you reload the menu so that it displays the new items in that list. So there you go. So that's how the long callback is handled, which is good. So now that's done. Oops, I've pasted that there. That's no good there. Let's put that above that menu. You can't paste it below the menu that's actually going to use it. So let's put it below there. Or you certainly shouldn't. There we go. Okay, so now that's done. Now what we want to do is we want to look at how the window gets displayed. Okay, so now what we want to do is we want to work out what we're going to do when the task detail window is actually loaded. So when you click on the menu here, it then provides the index of the row that's been clicked. So we need to be able to handle that, which we've done before. That when it's clicked on an index, it then updates that variable that stores the currently selected task. And then we need to take that and we need to display the task inside of the task detail window here. Notice how I've not used the full size of the window. I've actually left a bit of a margin by about sort of 5-10 pixels around so that it displays a bit more clearly rather than having your text right on the edge of the window. Okay, so how do we do that? So the first thing we need to do is we want to create our task detail window load function, which was referenced earlier when we click inside of the what happens when we're doing the click handling. So the select click was referenced this function here. So what does it do? Well, when we do that, the first thing we want to do is we want to get hold of the root layer and create a root layer so that we can then start pasting things on top of the root layer. So we create our window, we get the root layer, and what we do then is we work out the size, the bounds of that root layer, so that we've got the full bounds, the full size of that window, so that we can utilize the full size of that window. So this calculates the bounds, so the XY coordinates of the top left and also the height and the width. We then use that bounds to create our own bounds, which are going to be slightly smaller so that we've got that margin. So we create a new rectangle of our slightly smaller bounds, starting at 5.5 and finishing at the width -10 and the height -10. So we've got a little bit more space there. And then we create our text layer, pasting that onto those a text layer using those bounds that we've just created. Good. So we created our text layer upon which we're now going to be adding all of that, all of our text onto. Then what we need to do is we need to add the text itself with a little bit of sanity checking. So we need to make sure that the when we clicked on a row, it's not given a negative index. And we also need to make sure that the index that's been provided actually exists so that it doesn't go beyond the task count. If all is good, then what you need to do is you do this bit of code. Basically, we go to the task list array, we give it the index of the current row that's been selected, and then we extract the text from the array for that task. Once we've done that, we then, this parameter here, this is the where this text is going to be loaded into, which is in the task detail layer, and we're setting the text content. So basically, it takes the task detail and loads it into the task layer. If this bit fails, so for some reason you give it an invalid index, then we just put an empty string inside of there. You could put some sort of error in there if you wanted to. But that's the main logic that we need. Once we've done that, we then just get to styling the content. So we say, okay, let's set ourselves use the Gothic 24 font. There aren't a lot of fonts that you can use. There's only a few inbuilt ones, and this is using one of the inbuilt font sizes. So if you look at video number 1, that will tell you the list of the full different options there are available on the Pebble, but just use that one. Then we need to tell it that the text that we've put in there is going to be aligned on the left, so left aligned. Then we need to say that, okay, we handle overflow of text per line by wrapping it so that it wraps onto the next line. Then we need to set the background color and the foreground color of the text. And we can do that quite easily using the inbuilt colors in the Pebble library. The G color clear, which is a clear background, and then black for black colored text. Obviously, you can change that to whatever you want. Once we've done all of that text, we need to make sure that we add all of that text box that that text layer that we've just done. We need to add the text layer that we've just created here to the window layer. There we go. And the way we do that is we use the task detail, getting the layer here, and then we add it to the layer here. There we go. And that's pretty much it. So that's pretty much it for loading the task detail window. That's all you need to do. Okay, pretty straightforward. Get the text that we need to display and then display it on there. Obviously, that's the loading function, the dot load that we hooked into. We also need to handle the dot unload, which we do using the creating another function for the unload, which is the task detail unload. There we go. So here we go. And that's the task destroy. And that's pretty straightforward. All we need to do is when you unload it, which is usually when you click the back button, the left-hand button, all you need to make sure you do is we just destroy the task detail layer. This releases the memory that's been allocated for it, so that then it's all done. Speaking of which, we've done the window load, so we should do the same for the window unload. There we go. And again, the same sort of thing happens when you unload. All we're doing for the, oh no, that's not the right one, hang on. When we're unloading the window, the main window, we just do the same idea. We just destroy the menu layer that we created. That is the menu of tasks. Okay, so now what we need to do is we need to handle what happens when a new task is added. So the callback for this, the trigger for this is tapping the screen. So when you tap the Pebble like this on the program, it then calls the tap handler function. When the tap handler function is called, it first of all checks to see if the tap has happened within the last 500 milliseconds. So basically, a double tap only counts if we go tap tap like that. We don't want the user just tapping, changing stuff. It's got to be a full-on tap tap, okay, within 500 milliseconds. So what we need to do is when they tap, if it's not been within the last 500 milliseconds, then we update the last tap time so that if they tap again, it will register it. But if it is been tapped within the last 500 milliseconds, then we need to start the whole dictation process that goes through and records a new task. So how does that work? Well, the first thing we need to do is we need to create the function that is the tap handler function that we've referred to in our main window that we hooked into before. And what we need to do here is we need to calculate the time of the tap and the last time. So we get the current time, which is here. Then we need to calculate the total time, which is the current time in seconds, which is great. And then also the current time in milliseconds. And we add those together, which is fine. Then what we do is we calculate the time difference between the current time, the current total time, and the last tap time, which is good. And once that's done, then what we need to do is we need to check to see whether it's outside or inside of the last 500 milliseconds, which is what we do here. So if the last tap time is greater than 0, so someone has actually tapped, because remember at the start of the program we set the tap time to 0, and the difference in milliseconds is less, the time difference milliseconds is less than the double timeout in milliseconds, then we need to what do we do? Oh yeah, then we start to call the dictation. Okay, now what we don't want to do is if it's already dictating, so dictation is already in process, so there's already another layer on top that's using that dictation process, then we just return because we don't want it trying to double record. If there is no dictation service running, then we create a new dictation service, which we say, okay, we're going to be recording, and it's going to have a maximum task size of the size of the character multiplied by the task length. So it'll be up to 100 times by the size of a particular character. And then it's going to be handling the dictations. When that's done, it will be handled by the dictation service callback. There we go. So, and this only starts the process. It doesn't finish the process. Okay. Then we start the session, which is the session we just created. Now that we've created the callback for it, which is the handler for when it's finished. And then we update the time. So you can see that here, set the last tap time to 0 so that it's not got a last tap time. And otherwise we just, if that fails, then we set the last tap time to the current tap time so that we then know it's within, if it's then tapped again within 500 milliseconds, it would then go and start recording instead. Okay, so this is the handler for the double tap, and that's what happens when it's double tapped. It calls the dictation session, and then we can handle that later on using the dictation session callback. Okay, so the dictation session callback, really quite simple. All we need to do is you say, okay, yeah, we'll put this above here, so it's above there. There you go. So the dictation session callback, all we do is we get at the end of it, we get the transcription that's come back from the dictation callback. You don't have to handle any of that. It's all done automatically, which makes it really simple to code. You get the transcription, which is the thing you need, okay? And first of all, what you do is you check that it's been a success and it's not an empty transcription, because you don't want, if the dictation session fails, then you don't want it to be saving that a failed, anything failed from there. And also if they have dictated it, but there's nothing to actually add, so it's an empty task, you also don't want anything being added to the task list. So if it's successful, you then need to do the sanity check to make sure that the task count is less than the maximum number of tasks. So if it is, we know we can add another one. And then what we do is we go and we get the transcription and we save it into the array here, which is the, you go to the task count here, and so you go to the array of tasks, you give it the index of the task count, and then you set the text to the transcription, making sure that you don't, the length of that is the maximum task length -1. The reason being is so that once that's done, you then add the null terminator to that task. So you stick that null terminator on the task, and then you add you increment the task count to ensure that the number of tasks in the task count has been increased by 1, so that when you call the save tasks here, it knows to save including the extra new task that you've done. And then finally, once all that's done, you need to call the menu layer reloaded data function, which will then reload all of the menu. So it'll just tell it to reload the whole menu. Once that's done and you've completed all of that and you've done your dictation, you then need to destroy the dictation session in order to A, free up resources, and B, so that the previous tap handler can then be using the dictation service again, and set the dictation session to null, and that will wipe that out as well. Okay, so that is the project almost entirely complete. All we need to do is we just need to save the project. So we'll just save it. Once your project has been saved, which you can see here, let me just go to mine. Once your project has been saved, what you can then do is you can then build the project. The way you do that is we do Pebble build. There we go. Oops, I'm not inside of the project, that's why. dir, there we go, cd space task list. Pebble build, there we go. There we go. And it will go through and it will build the full project. So just to show you that code there, what I've done here, So you save the project, make sure you save the main file and save the project setup. You do Pebble build, and that will then save the project and it will build all of the files. If it's got any problems in there, then you can then paste the error code into ChatGPT and see if you can get that to help you, or just check my main code. Once you've built, you then have two options. If you're just testing it on the computer, you can install it to the emulator, which I will show you, but the emulator doesn't handle the double taps very well. I couldn't get it to get the accelerometer registering double taps, so it wouldn't allow me to add a task. But you could do that. Normally for your apps, you can just go Pebble space install space -- emulator. It does normally work. And then you just give it the name of the emulator that you want to use. This is actually the name of the code that's used for the individual type of Pebble watch. So the different versions of Pebble watch have a different name, and I've just given it the wrong one. Oh, it's because I've given it in titles, not in capitals. D, all right. There you go. And then it will start the emulator and it will emulate the full program, showing your task list. So here is my full program there, showing my task list. Unfortunately, I can't get it to simulate the adding of a task using the accelerometer. If anyone knows how to do that, please tell me, because it wasn't working on my machine. But there we go. So there's the task list done. And then if you then want to install it onto the Pebble watch itself, you do that via the phone, and you give it the IP address 192.168.1.31 on your the IP address of the Pebble of your phone. In order to do that, you need to find this the IP address, and you also need to enable developer mode on the Pebble app. So you go to the Pebble app on the phone, click on your Pebble that you're going to send it to, and then down at the bottom it will have a option that says like a toggle for developer mode. Click on that toggle to enable it, and then it will show you the IP address that you need to send it to. Type in the IP address, and then it will send it straight through to the phone, to the watch. And you could probably see that coming through on my watch now, and it is now installed. Double tap. Hello, please add some chocolate. Thank you very much. And you can see here, it will then go through to the dictation service. Please add some chocolate. Thank you very much. Oh, that worked really, really well. And there you can see it. It's now added to the watch, straight on there. And if I click on it, you can see the full detail of the task, which is great. And then if I go back and I long click, it will delete. And now it goes back to the no tasks. There you go. So that's a really, really simple application. Not too much code, but shows you how you can use the dictation service and how we can create menus inside of the Pebble app. I hope this has been useful. If you've got any more requests or questions or need any clarity, then please let me know. And if you did like the video, then please like and subscribe. Thank you very much.